We're going to be looking at compound inequalities. Compound, more than one thing's going on. Inequalities, we know those are our greater thans, our less thans, our greater than or equal tos, or our less than or equal tos. And you're going to see two connecting words, and or, and they are completely different from one another. So here's one example. X plus 3 is less than 1 and x minus 4 is greater than negative 12. This is a compound inequality that we'll be solving. Alright, we're going to start with intersections. The intersection of two sets. This is the and word instead of or. And the symbol is the upside down U. So this is a symbol for intersection. And what it means is what are the elements in both set A and in set B at the same time? Where do they intersect? Example 1 says, what if set A were the numbers 3, 4, 5, and 6? What if set B was 5, 6, and 7? Where do they intersect? So A and B both have 5 and 6 in them, so they intersect at the numbers 5 and 6. Union's going to be completely different, but intersection is where they intersect one another. If you had set A here and you have set B here, you're going to see 3, 4, 5, and 6. And over in set B you have 5, 6, and 7. So this 5 and 6 is where they intersect one another. Alright, so let's solve a compound inequality with the words and or intersection. So you can say the word and, you can use the word intersection, or you can use this symbol anytime you want, and they all mean the same thing. So we just solve each inequality individually, and then the solution is where they intersect each other. So example 2, I went ahead and solved it for you. Just solving x plus 3 is less than 1. All I did was subtract 3 on both sides, solved it, and got x is less than negative 2. And on the other one here, all I did was add 4 to both sides and got all numbers greater than negative 8. So one way to find the solution is to graph them individually and then think of the two graphs together. If you're dealing with the numbers negative 2 and negative 8, you're going to want to line them up on the graphs right on top of one another. So if negative 8 is on this graph here, put it here. Alright, so whatever numbers you're dealing with, go there. Okay, so all numbers less than negative 2 and all numbers greater than negative 8, where do they intersect? These points match, these points match, they intersect here, here. So it looks like they're intersecting between negative 8 and 2. So all the numbers in here, they're intersecting all in here. And then what happens at the endpoints? Do they intersect at negative 8? Is negative 8 an answer in this graph and in this graph at the same time? And it's not an answer in this second graph. Negative 8 is not greater than negative 8. Since it's not a solution here, it can't be included. Same thing with the 2 on the right. The 2 is not an answer in this graph, but it is here. It's right there. But since it's not in both, you can't include the 2. So our answers are from negative 8 to 2. That's interval notation. And in set builder, the set of all x's so that, and now here's a new way that I want you to write anytime you have an intersection between two numbers. You put the smallest number to the left, you put the biggest number to the right, you put your x in the middle, and the less than symbols go there. Okay, so this means that x lies between negative 8 and negative 2. Okay, all these numbers lie between -8 and -2. -8 is less than all of these, which are less than all of these. Let's just check a number. I know that -6 would be an answer in both. So if I change this x to a -6, is -8 less than -6? Yes. Is -6 less than -2? Yes. -6 lies between -8 and -2. That's how you read it. Okay, example 3. Let's try this one. Let's go ahead and solve one. Let's solve these two guys right here. So I've got 2y is less than or equal to 4y plus 8. I've got to solve him. The connecting word is and. I also want to know where 3y is greater than -9. Alright, so if we're solving for this one, I'm coming up with -2y is less than or equal to +8. What happens when I divide by a -2? Very important to switch the sign. So far I've got y is greater than or equal to -4. On this particular problem, all I have to do is take y and divide it by 3. So I'll take the -9, and divide it by 3. And I'm coming up with y is greater than or equal to -3. So one way to do this is to graph them both. So if I want to graph y is greater than -4 and y is greater than or equal to -3, the numbers I'm dealing with are a -4 and a -3. Line them up on the two graphs. So -4 would be to the left. Do it on both. So all numbers greater than or equal to -4. All numbers greater than or equal to -3. Alright, so I'm looking for the intersection of these two. Where do these two graphs intersect? It looks like this point is in common in both. It looks like this point is in common in both. It looks like this point is in common in both. What about at -3 itself? Is -3 an answer in both graphs? Because of that, we're going to include it. And all the answers look like they go to the right forever, so it's everything to the right. This is the intersection of the two sets. So in interval notation, it's -3 to infinity. The -3 is included, so make sure to put a bracket around it. Alright, it's where they intersect. Example 4. Let's solve these two. So where are these solutions and at the same time these solutions? Where do they intersect? So on x plus 2 is greater than 3, we're going to subtract 2. And we'll get all numbers greater than 1. You know, if you don't feel like writing the AND symbol, you can always use the intersection symbol instead. Looks like I need to subtract 1 on both sides. 2x is less than -4. And then I'm dividing by a +2, not a -2. So the sign doesn't change. Just because this negative sign is here doesn't mean you flip the sign. I'm dividing by a +2. So I want to know where are all the numbers greater than 1, and at the same time all those numbers need to be less than -2. Now this one you can probably do without graphing these two. Think of where do all numbers that are greater than +1 intersect all numbers that are less than -2, and they just don't. This one's going to be that there's no solution. Let's try it this way in case you'd like to see it. All numbers greater than 1, all numbers less than -2. I'm dealing with a -2 and a +1, so line them up. So where do all the numbers greater than 1 and less than 2 intersect one another? And now you can see there's no intersection points in common whatsoever. So there's no solution. The symbol in mathematics is this, and Course Compass will just say, you know, type an N for no solution. Alright. Completely new idea. Union of two sets. The union of two sets. Now the symbol is a U, which is easy to remember. U and union and a U. And the connecting word is or. This means instead of the intersection, where are they in both at the same time, this is the elements in either the first set or the second set. You take, or both, you take everything. So if we go back to like this example that I had before, if I change it to find the union of the two sets, it's everything from set A, which is 3, 4, 5, and 6. Take those as answers, or everything in set B, which is 5, 6, and 7. Well, 5 and 6 is there, I would just add my 7. If you like that diagram from before, you're just including everything. Union. Include all of it. All the answers in set B, or all the answers in set A, or both. You include everything. Okay, let's try number 6. Again, we solve them individually, and then we include everything in both graphs. Alright, number 6, I solved them for you. So I just added 1 to this one, to both sides, and got y is greater than 3. And looks like I subtracted 2y, and I subtracted 5, and I ended up with y is less than 1. So the two numbers that you're going to want to put on your graph are a 3 and a 1. So make sure you put the 1s, line them up to the left, and the 3s to the right. Now let's graph them both. All numbers greater than 3, all numbers less than 1. Now I'm looking for the union of them both, not the intersection. If this were an intersection problem, they don't intersect and there wouldn't be an answer. But the union in both, you include everything from the first set, so all numbers greater than 3. You include everything from the second set, so all numbers less than 1. Or you include them both. So it's like you're including all of the answers. Everything greater than 3, or everything less than 1, or both. So it looks like we've got two different branches. Anytime you have two separate branches, when you use interval notation, you're going to have two separate interval notations. So this first one is from negative infinity up till 1. The second one is from 3 to positive infinity. And what you need to put in the middle is either the word or the union symbol. Alright. Let's try another one here. Example 7. Where are all numbers less than 5? Well, that one's already solved for you, so all we need to do is graph it. Or all the numbers less than negative 3. So I'm dealing with a 5 and a negative 3. So my negative 3's would be to the left, my 5's would be to the right. So I want all numbers less than 5, or all numbers less than 3, or both. So start by including the first set of all the first ones. So I'm going to start by including all numbers less than 5. Then I can also include all numbers less than negative 3, but they're already in here. So saying all numbers less than 5 includes all of these, so that's your answer. All numbers less than 5. So from negative infinity to 5. Let's try 8.